Now we will talk about deleting a node from a linked structure and clear the whole linked structure. First, delete a node from a linked structure. Delete the first node is a special case. Now we have a linked structure, and in this linked structure, we store points, and head pointed to this linked structure, the first node of this linked structure. Now the first node is very special. So if we want to delete the first node, we use a current, another pointer, except the head, we need another pointer current. So we set the current equal to head. So the current, this pointer point to the first node in the linked structure. Now we want to delete this node. And then we set this is the step one. The next step, we update the head equal to head next. Now the head doesn't point to the first node, it will point to the second node because head equal to head next. The second node, its address is head next. So the head points to the second node. This is a step two. We update head pointer. And then the third step, we delete current. Step three, delete current. So we know that all this node are created use a new pointer. So we use a new pointer. It's not new pointer, new operator, new node type PT. So we create this node, use new operator. So we need to explicitly delete this node to release the memory space allocated to this node. So we need to call the delete current. Delete current means release this memory space. It doesn't mean delete this variable, this pointer current. It just release the memory space allocated to the node. This is how we delete the first node. And now if we want to delete a node in the middle or the last node, we need another pointer. We call it previous. So we need two pointers, current pointer and the previous pointer. Now I will draw another linked list. The first node, the second node, third node, fourth node, last node. Head always points to the first node of linked structure. Now we need two pointers, current and the previous. Now if we want to delete this node, the current point to the node we want to delete. So what we do is we need to know the address of previous node. The PRE, the previous, is a pointer, points to the previous node. And then we set the previous next equal to current next. We bypass the current node. And then we delete current. So here we have the three steps. Step one, the current is equal to previous next. Current equal to previous next. This is the Step 1. Step 2, we bypass the current node. The previous next equal to current next. Step 2. Step 3, we delete current. Step 3 means release the memory space allocated to this node. So if we want to delete a node, we need to know the address of previous node. So in this case, in this example, the previous pointer point to the previous node. Okay, this is the delete a node from a linked structure. Now this one is we clear a linked structure, means we delete all nodes in the linked structure. We clear the linked structure. Okay, so here we need the head pointed to the first node of the linked structure. We need another pointer, current. This is our linked structure. Head pointed to the first node. And the current the current is a pointer, and if the head is not a null pointer, the while loop, if the head is not the null pointer, that means now we're not at the end of the linked list. So we will set the current equal to head. Step 1, current equal to head. And then we update the head. We move the head to next node. The head equal to head next. So now the head pointed to the second node. And then we delete current. Delete current. Now after these 3 steps, we delete the first node. Now the head pointed to the second node. And then we repeat these 3 steps. Now we're not at the end of the linked structure. So the current, we set the current equal to head. And then the head equal to head next. Head pointed to the third node, next node. Step 1, step 2. And then we delete current. Release the memory space allocated to the second node. So now in the second iteration, we delete the second node. And then we repeat these steps until we reach the last node. Now the head points to the last node. And the condition is true. The head is not the null pointer. And then we have the current point to head. And then head equal to head next. This is the last node. So the head next is null pointer. Now the head is null pointer. Head is null pointer. And now we delete current. Okay. Step 1, step 2, delete current. Delete current means delete the node. And now the current is null pointer. Null pointer. So now this is how we clear a linked structure. So okay, we will talk about this in the examples. Okay, now let's take a look at 3 examples. We will see 3 examples now, and the first example is in the point. In the point 1.txt file. this code file is posted on the canvas. So in this example, we have the point class, and we have the node type struct. We create a linked structure to store a collection of int points. So that means this x, y are all int, the int points. And then we will see the insert operation. And we will see the reverse operation, and we will see the clear operation. And then the second example is in the employee.txt file. It's also posted on the canvas. So in this example, we have the employee class. And we also use the node type struct. And we store a collection of employee objects in the linked structure. So we will see the insert operation, search a target employee and search and remove the target employee. And traverse, print all the employee in the link structure and clear the link structure, remove all nodes. And then the third example is in the point template.txt file. In this example, we have the point class template. So the point class is a template. And we also define the node type struct template. And then we will see the insert, reverse, and clear operation. Now let's start from the first one, the point1.txt file. Now I will stop sharing this one and share the point1.txt file. Okay, here we have a point class. And this point class, the attributes x and y are all int. So that means this is a int point. And here we also overload the output operator. We overload the output operator. And then we will go to the test linked point here. This is a test linked point. So this is a node type struct. Node type struct, the data type is point. So that means in the nodes, we store points. or we store the point objects. And then we have two constructors, default constructor and constructor with one parameter. We already talked about this in the previous videos. So here we have two pointers, head and current. And then we prompt user to enter X and Y. So if the user press enter 1 and 1, we create a point. The point is 1 and 1. And then we call the new operator to create a new node. Create a new node. This means this statement means we create a new node. We create a new node and the user entered point is 1, 1 is here. And the head pointed to this new node. So the head equal to new node type point, the PT, we create this new node, head point to this new node. This is the first node. The first node, this is the special case. And then after we add the first node, we can use a while loop to add the remain node. Use a while loop to add remain node. I will write here. This is the first node. Then we use a while loop to add the remain nodes. So we prompt user to enter X and Y. The condition is if the user entered X is not 0. So we check the X. If the X is not 0, we create a point object, or we say we create a point. And then the current equal to new node type PT. So this means we create a new node. Now the current pointed to this new node. And this new node, the next is now pointer. Now assuming the user entered 2, 2. So in this new point, in this new node, we have point 2, 2. This is the step 1. And step 2, the current next equal to head. Step 2. Step 2, current next equal to head. The current next, now the current next is now pointer. We will update this. It's equal to head. So that means it will point to this node. Update the current next. The current next equal to head. This is the step 2. And then the step 3, the head equal to current. The step 3, we update head. Now the head equal to current. Now we have what? We have the head pointed to node contain 2, 2, and the node contain 2, 2 next point to the node contain point 1, 1. And we will repeat these steps. And then we prompt user to enter X and Y. Now the user enter 3 and 3. We go back to the loop condition. X is not 0, so we create node, we create point 3, 3. Create a new node. Create a new node. The current point to the new node. 3, 3, and the current point to the new node. So the step 1, current equal to this new node, point to this new node, and then the current next equal to head. Now the head pointed to the node contain 2, 2. We update the current next. The current next equal to head. Current next equal to head, the step 2. Step 3, we update head. Head equal to current. Head equal to current. Now we have 3 nodes in this link structure. Step 3, forget this. 3 nodes in this link structure. Head pointed to the first node, and the point 3, 3 is in the first node. The second node is a node contain 2, 2. The last node is a node contain 1, 1. So we will repeat this while loop until the user enters 0, enter X at 0. We will exit the while loop. This shows how we insert or how we add a new node to the front of linked structure. And then we have the while loop. This while loop will print out all the points in the linked structure. So we need the current pointer. We don't move the head pointer. So the current is not null pointer. We print out the data. This data is the point object. It's 1, 1, 2, 2, 3, 3 in this example. And then the current equal to current next. We always move current. We don't move head when we traverse the link structure. And next while loop is we clear this link structure. So the head is not null pointer. The current equal to head. Head equal to head next and delete current. So we move head to the next node and delete the previous head node. Delete the current. Okay, this is the point 1 example. Now let's take a look at employee example. This is the employee.txt file. We have employee class. In the test link, and now the two constructors, default constructor and constructor with one parameter. We pass an employee object to the constructor, and this constructor will assign this employee object to attribute data. This is their initializers. Okay, now in the main function, we have 3 pointers. previous, current, and had. Previous, current, and had. And we create this new node use default constructor. The default constructor will set the next signal pointer. We'll use the default constructor of employee class to the data user to use the default constructor of we know the data between this is data and this is next. Data is an employee class. Sorry, data is employee object. This employee object is created use default constructor. The employee ID is 0. Name is null pointer. Department name is null pointer. The head points to this new node. And then the next 3 steps, we call the 3 mutators: set ID, set name, set department, to change the employee information. Now we change the employee ID as 5. Change the employee name as Mary. Change the employee department as CSE. Now, we use these 3 statements to change the employee information stored in the first node. And then we print the head. So we add the third node ahead point to the first node in the link structure. Here point to the last node in the structure. And then we use the while loop. So this we don't use the while loop. We manually and then we will do the while loop. This condition is if the user enters the new node to restore this employee, the current point to this node. Is this node to the new node to transfer the employee information. Current point to this node. Step 1. And then step 2, the PRE next or the point. This is a print or the traverse the link structure. And then the next one for the employee, this one we implement this search and remove operation. So this means we will search a target employee from the linked list, and then we remove this employee from the linked list. So the search here we only we prompt user to enter employee ID. So if the ID matches, the user entered ID, we will remove this employee. Now the first node is a special case. If the target employee means the employee will to be removed. If the target employee is in the first node, in this node, in the first node, and we will remove the first node. We know remove the first node is a static. So the head onto the first node. If the head data get ID is equal to the entered ID, we remove the first node. So the previous and if the target employee is not in the first node, and then we will use a while loop. So that this in the contained in else, and we use a while loop to search the target employee. So here we know if we want to delete a node, we need to know the address of previous node. So here the previous pointed to the previous node, and we use a current to point to the node contain the target employee. So here it's a similar to the search and remove operation we talked about in the last video. So in the last video we use a current. So we want to find the node contain the target point. But here we don't want to know the node. We don't want to know the node contain the target point. We want to know the address of previous node. Okay. This is the target node, and this is the previous node. Previous pointed to the previous node, and this is a target node. We want to know, and this node contains the target employee, but we need to know the address of previous node. So here we use a previous next as a current node. This is the previous node. So what's the address of current node? The address of the current node is a previous next. So now instead of use current, we use a previous next. If the previous next is not null pointer, this is the one condition not end, we're not at the end of the link structure. And another condition, the previous next data dot get ID not equal to ID, and we don't find the matched employee ID, not match. If we're not at the end of the link structure and we don't find the matched employee ID, two conditions, 1 and 2. Okay, two conditions. If we are not at the end of the link structure and we don't find the matched employee ID, we move PRE, previous pointer. The previous pointer point to the next node, and we will do this while loop until the one of the condition is not true. So if we exit the while loop, that means we're at the end of the link structure. That means no, we don't find the matched employee. Or we're not at the end of the link structure, and it means we find the matched employee. So after the while loop, we use the if statement. If we're not at the end of the link structure, that means we find the matched means we find the matched employee. So we need to delete this node. Delete this employee means delete the node contain this target employee. So we use the current equal to previous next. So the current equal to previous next. Current equal to previous next, the step 1. Step 2, the previous next equal to current next. So that means previous next equal to current next. We bypass the current node. Step 2. Step 3, delete current. Step 3, delete the current. So it means release the memory space allocated to this node. 3 steps. So if we find the matched one, we delete it. If we don't find the matched one, we just print this message. The employee is not in the linked list. Okay, this is a search and remove. Search a target employee and remove it from link structure. We will use this in the lab 3. We will use this in the lab 3. So please be sure you understand this code segment. Okay, next to while loop. This while loop, after we remove the employee, we print out all the employees in the linked structure. So this is a traverse the linked structure. The current, we move the current equal to current next, print the data. And then we release all the nodes. So that means we clear the link structure. We need a current equal to head equal to head next, and delete the node. Use a while loop to delete all the nodes in the link structure. Okay, here we have the we define the struct node type, but the difference is this is a struct template. Struct template type name T, and the struct node type. The data type is T. Here the data type is not a specific class name or the data type. This is a generic type T. Type name is T, generic type. And then the for the constructor with one parameter, the parameter type is T. So we define this, we can put the struct template in a file, in a CPP file. For example, the node type .cpp. And then in this file, we just include the node type .cpp. So that means we don't have to add the node type struct in every file contain the main function. We can add this as a header file. Now we use the struct template. Now in the main function, when we use a node type, we need to specify the actual data type. So here in this example, we read the node type, and then we need to specify the actual data type. The actual data type is employee class. So this means the employee class name will replace the T in the node type struct. So every time we use a node type, we need to specify the the actual data type. And now this one, specify the actual data type, specify the actual data type. And here, actual data type, specify actual data type, node type employee, node type employee. So if we use a struct template, every time we use a node type, we need to specify the actual data type. It can be employee. In the point 1, we will use a point here, specify the actual data type is point. Okay, so for the other part, we don't change the other code, just the node type. We cannot just write the node type. We need to specify the actual data type. Okay, this is the employee class. And now let's take a look at the point template. This is a point template.txt file. Here we have the point class template, and this is a template. And the attributes X and Y, their data type is a generic data type T. We don't write the specific data type int or double. We use T here. And then, okay, we go down here. Here we declare node type struct template. So the node type is also a struct template. So here we use a T, generic data type T. And now in the main function, when we use a data type, we need to specify the actual data type. Now, in this example, the actual data type is a point template. So we put the point here, but the point is also a class template. We need to specify the concrete data type of point. Now this is int. So when we use a node type, we need to add the point int here to show that in this node, we will store the int point. If we want to store the double point, we will write the node type angle bracket point. This is a class template name and double. So now when we create a node, star current equal to new node type point double. Node type double and parentheses, we will create a new node and current point to this node. And the data is what? The data is double point. Double point, now we use the default constructor. So that this is a 0.0, 0.0. And the null pointer. Okay. This is a struct template. For the module 2, we will stop here. And we have in the module 2, we have lab 3. I will talk about the lab 3 in a separate video.